This conference will now be recorded. This conference will now be recorded.
Good evening, all. This is Bhavani. I request all of you to kindly mute from your end. I can hear a lot of noises actually. So the session is about to start now.
So there should be an option to mute everyone. Can you check that if you can mute everybody? Organizer should have that access.
Yes, I'm checking.
Yeah, thank you. All right, we'll start the class. We can use our chat window for doing any communications because there are a lot of people in this particular workshop. So if you all keep asking questions, there will be a lot of disturbance and all. But today's workshop is all about understanding different applications of data science. So this will be kind of an introductory part of data science. So before starting the workshop, I just wanted to ensure that my voice is clear and my presentation is visible. So if somebody can use the chat window to confirm that. Yes, clear and loud. Perfect. Go on. Great. So today's session, what we will do is we will discuss about different applications of data science. We will understand how the life cycle of data science would be working. And this will be a 2-day workshop. So today will be an introductory part. The later part will be understanding what are the different areas to cover, what are the things to learn, what are the different industry areas where we are using data science for, how will be the real life cycle of a data science project look like, what should one do to get a kind of entry in or job into a data science part. All those things we'll be discussing in our 2 days workshop. All right, so without any ado, I would start. My name is Sitaram and I have around 14 years of experience. I work as a data scientist for one of the major MNCs, and I have a great passion in also taking sessions. I do a lot of workshops. I do conduct conferences and different sessions across India and world. And I also have a passion to take trainings and so on. So that's the reason I'm here. Here we are conducting a free workshop from the collaboration with Career IT. And this workshop's prime intent is to make everybody aware about what the technology is, how this is using, and if somebody has an interest in this technology, what are the different steps they have to take, right? That is the prime intention. Let us go forward in the session without any other things. I request everybody to turn off the videos. So that for your privacy sake, please ensure that you are turning off your videos. So just to understand, data analysis is there for a long time. Right? There were a lot of these experiments which are conducted for many years ago.
Hi, Sita. Sorry for interrupting. I could see someone on video conference. I mean, like I can see someone switching on their video.
Yeah.
I request all of you to turn off your camera videos.
Yeah, I told him, Bhavani. Just now I told him. He turned on.
Yeah, organizers, can you also close the video call, I think that facility should also be there. Please check that. You can mute everybody and also you can close their video connections. All right. So let us continue. I think this hits. Yeah, I think now things are clear. Maybe let us continue. So data analysis is there for quite a long time. We were doing a lot of data analysis right from the early 1900s. There were a lot of design experiments which were conducted. R.A. Fisher is a very prime person who was doing a lot of data science experiments. He was a professor. Likewise, there are different experiments which were conducted in many years. But what is the difference between that experiments and current things which are trending in the market right now, right? There are a lot of things which has helped in the past for conducting these experiments, because the businesses were having this requirement that, if I have so much of data, how I can make meaningful insights of the data. It is there for a very, very long time. A lot of people are doing experiments and working on that. So there was a lot of these insights which are being coming for a lot of years. But the thing which has changed from the past and the present is the availability of a lot of other things. So let me talk about that. So there was this AI which was there. So data science, AI, we will discuss about what are the minute differences between all these things. We will see like how these are different in basic sense. So it was there for a quite long time, but it went into something called as AI winters in the middle. So 1950s is the, I would say, like in initial years, people started to understand AI, trying to do a lot of data science experiments. And back in those days, the availability of data was a big problem. People started to collect information for doing the data analysis. But what happened is they were not able to they were not able to have a sustained information, and that has created a AI winter somewhere around in 1975. Before that, there were very, very popular algorithms like neural network, which is current base of your deep learning algorithms, were invented. There were perceptron models which were invented in 1958, and different other things were invented. But the main disadvantage was the availability of data. The people were not having huge amounts of data collected. Second one, people do not have ability to store data. Now they have data, but imagine they have video images, they have pictures and all those things. The ability to store the data was not very prominent. So that has led to something called as an AI winter. AI winter is nothing but there is a hype, and which people thought that, okay, now world is being changed, AI is going to take or rule over the world, a lot of automation could be done and all that stuff. And then suddenly there was a deep valley. That valley is called as an AI winter, and then people realized that this is not going to help us, and it went into a deep valley. Later, after a few years, somewhere around 1989-90, there was again a bubble in AI, because it was because of the emergence of handwritten characters. So people wanted to understand that if somebody is writing a handwritten characters, specifically identifying on postcards, people used to provide postcards, and identifying the zip codes or pin codes on your postcards, and identifying which particular area this postcard should go, which was a requirement. And people were trying to create applications, computer applications, vision applications, which can look at the postcard, identify the pin code, and then based on that automatically sort your postcards. So that was the requirement. And there was a lot of research which happened, which has also emerged one of the latest technology, which is called as convolutional neural networks. So convolutional neural networks are again part of neural networks which are primarily using image processing for identifying handwritten characters or digits. That also took a very big hype cycle or a leap, but later again fell down. The reason for this particular fall is that they were having plenty of data. They were having plenty of image samples of images of handwritten digit zip codes and so on. But the problem was they were not having enough amount of compute capacity to do the computation. So the first fall was where they do not have enough amount of storage capacity. The second fall was where they do not have enough amount of compute capacity. So both of them are very crucial things for doing a data science or an AI projects. So currently we are in a phase, again, there is again a lot of hype. People are again coming up with a lot of algorithms. People are trying to create a lot of applications, and there was a lot of this hype again created from 2017 onwards. And now people are thinking that, will this sustain, or will this be again a hype cycle? Will again it will go into an AI winter, or so on and so forth. So if you ask me, I would say that the current stage we are in, we are very fortunate that because we have a good amount of data storage capacities, we have good amount of compute capacities, we have good amount of availability of data, and we also have a good amount of algorithms which are coming up. So it is a deadly combination we are currently in, where you have cloud computing, big data, you have good algorithms from Google, Facebook. So if you have heard about TensorFlow and PyTorch, these are some of the deep learning algorithms which were invented somewhere around 2017 odd. Then those are actually contributing towards a lot of this hype. People were thinking that now, because all these things are coming hand in hand, we have good storage capacities, we have good compute capacities, we have good algorithms available. So all these three coming together are becoming a deadly combination which can sustain this momentum for a quite long time. Right? So this momentum of currently AI, data science, all these things coming together will be sustained, according to me, at least for another 10 years or 15 years. After that, there could be a lot of changes could happen, but according to me, this could sustain for another 10-15 years is what I'm thinking. Because we are also aided with a lot of other application areas which are coming in this particular space. Today's session, we will be discussing about all those application areas, how AI is contributing towards that. All those things we will discuss in great detail. Right? So here the point we are trying to make is it going to burst again, or is it effective? The excitement will fade away, or is it the next burst, or probably contributing to the next AI winter? So these are a couple of questions, and what I could say is there is at least if not a great amount of boom, but at least there is an excitement in creating applications, in creating areas which can help a greater human. Right? So we also understand that the technology cycle is changing very rapidly. The combinations of cloud computing, combinations of DevOps, and data science. In data science also, usages of heavier computings like GPUs and all, those all being used very rapidly. And coming the years, there are a lot of things coming up in the space. There are also a lot of cloud providers providing tools. For example, in coming years, you might not be doing a lot of coding, but you might be well versed with the tools available in the market to perform some of these tasks. So all those things are picking up pace very rapidly, which also provides a kind of inclination that we are going to sustain this for a quite long time. Now let us understand the contribution factors. We will see like how the data is contributing it and how is it performing. So data is everywhere. We know that data is everywhere. You might have seen this kind of slides, other presentations also. So data is kind of increasing a lot. We are creating a lot of data. We are consuming a lot of data. You're seeing tons and tons of data is being created, and this particular presentation is little dated, but if you're seeing in 2020, you are having these abilities of connected devices. We are having the abilities of devices like mobile phones, laptops, all those things are providing a huge amount of data, and we are trying to use that huge amount of data for our data processing. From a business perspective, if I'm looking at from a business perspective, data science is used in the business context. Now, from a business perspective, what are the data which is being used and what are the applications related to it? If I want to look like that, the first and foremost data which will be used from a business perspective is the transactional data. Now, what is transactional data? Transactional data is the data in which you're doing regular day-to-day work. Imagine you are like a retail company, like a grocery store, or you can think like in Indian context, you can think like a D-Mart or any other Reliance Fresh, Reliance Smart. If you take in the US context, you could think like, Walmart or Kmart or some other company, right? Where you're trying to do a regular transactions. So now what are these regular transactions? Suppose people are trying to buy some groceries, they are trying to buy some bread, they're buying milk, they're buying 1 kg of sugar or whatever. They're buying or purchasing those items. So the track of all those items typically would become your transaction. Most probably these transactions will be kept into something called as operational data stores. Now, operational data stores are your regular facing database tables, which are capturing all this information, like what happened today, like how many kgs of sugar sold, how many kgs of rice sold, how many kgs of wheat sold, probably how many bags of some other product sold, how many soaps, detergent, whatever, right? You're trying to keep this kind of a track to understand your data. So in early years, the data analysis was very, very simple. So what they were trying to do is what we want to do is the data is getting stored in this particular tables. And when I was working in early years, we used to run our queries on your operational data stores. That was very, very old. But in initial years of data analysis, the queries used to run on your operational data stores, so that you try to understand, like, for example, I want to understand how many kgs of rice sold. So you could write some SQL queries. Most of these operational data stores will be RDBMS tables. So like Oracle or MySQL, PostgreSQL or DB2 or Microsoft SQL Server, any kind of RDBMS databases. And primary data analysis was done on these tables. So you try to write some SQL queries, you try to understand that how many kgs of rice sold, how many kgs of sugar sold, and so on. But the problem which has arrived at that point is because there is these tables are directly accessed by the customers. For example, a front-facing shop is directly linked to the tables, these operational tables. And if you are doing some queries on the tables, it will slow down your entire actual operational process. Like somebody is trying to buy some product, and then you're running a query in the backend as a data analyst. What happens is it will slow down your entire data processing. So people, initially they were still doing this basic data analysis, but later what they decided is, because this is impacting your SLAs of your regular transactions, regular online transactions, so let us not do analysis in the daytime, but let us run these analysis in the night time. So slowly what happened is, initial analysis used to run on these tables, where we try to understand the data analysis, like how many kgs of sugar sold, how many kgs of wheat sold. These are some of the questions which businesses ask, because they want to identify the demand and forecast, right? We want to identify what is the demand, how many cases they should already order and keep it in the shop, so that they do not have any problems in serving the customers. So all those analysis used to be done, and because they are done in the real time, which is hampering your regular transactions, people thought that let us not do that and let us switch to something called as nightly process. And later, after a few years, what happened is people started working on nightly processes. So now what is nightly process? Mostly the shops used to work from morning, say 9 o'clock to say 8 o'clock in the night. And in the night time, the shops were not operational, right? This was again back 20 years back. These shops were not operational. So what they decided is, let us create some jobs which will run in the night time. The jobs will do the same work. they are doing something called as descriptive analytics. Descriptive analytics is nothing but we're trying to describe it like what is happening, what happened in the last week, what happened in the last month, and so on and so forth. We're trying to collate all this information in the form of some numbers. Now, the reason for collating all this information in the form of numbers, unable to hear anything. So are you able to hear my voice? A couple of people are not able to hear me. Yeah, I'm just checking the chat window right now.
Your voice is clear, sir.
Okay, I'm just checking the chat window, madam, just like that now. Right. Okay. So if you have questions, please post in the chat window. I'll be looking at that chat once in a while and then answer anything. So there was a question regarding after 15 years, the AI winter, the drop page. So that will affect the projects. Certainly it's going to see, this is a change which is happening, and the change, what we are trying to do is we have to try to ride the wave. That is a very, very important thing, that we have to ride the wave. So things which are actually in the momentum, we have to pick that and pick very fast. And because we are competing with a lot of other people, we have to be very quick, instant quick, so that we can identify the change, ride that wave till the wave sustains. And after some years, there will be another wave. We have to ride that other wave. So that is how the motive is, because the software and the things, whatever we are trying to see, might sustain for a couple of years. Like if I say 10-15 years is a quite long time, but eventually things might change and things might go away, right? One simple example which I would say is, I used to work as a big data architect back in 2012, and at those days, big data, the Hadoop, and there are some of the vendor specific tools like MapR, Cloudera, Hortonworks, and so on. They used to be very popular, and everybody used to be jumping on that particular technology because they want to get instant jobs and so on. But if you see past few years, the couple of companies have bankrupted. MapR is bankrupt. They have closed their offices. Now they are not using any of the services. Cloudera and Hortonworks, they have merged together, and they have created as a unique one single entity. If they don't do that, they could also be bankrupt. The trend has now changed from the on-premise big data services to cloud services. So everybody is now jumping on to AWS-based big data services, or Azure-based big data services, or maybe GCP-based big data services. So the point I want to bring onto the table is the years, whatever we are talking, it could sustain for quite a few years, but this wave may end. The prime motive of our motive is that how we ride that wave, and then if the wave is changing the tides, we have to shift to another wave for a sustainable future without losing our grip, right? So that is the motive. All right, so let us continue. So what we were discussing was, we were discussing about our transactional data. The prime things which are done in transactional data processing is what we call as descriptive analytics. Descriptive analytics is trying to describe what has happened. Like I want to know, like Maruti, how many cars are sold in the month of January, February, March, April, and May, right? So if Maruti has sold, for example, 10,000 cars in the month of January, 8,000 cars in the month of February, 4,000 cars in the month of March, and no cars in April and May because of COVID and other things. Imagine these are the statistics. Now, when I do that statistical figures, that is called as descriptive statistics, typically derived from a lot of transactional data. So transactional data will say like how many cars are sold in the month of January by dealer, by agent, and so on. Now I will collate all that information and try to identify that. Now why would I need to do that? Because if I know the demand, if I know that there are a lot of demand for a specific type of a car, or a lot of demand for cars in general, I might have to ensure that my production lines are sustainable for the demand of these cars, right? If I'm not meeting the demands, then there will be a lot of queue, a lot of wait time. People might switch their decisions. They might not wait. If you say, Maruti car is readily available, you're going to take that car. But if you say, sir, sorry, car is not available, it will take another 3 months, then within the 3 months, the person can buy something like MG Hector or something else, right? He might change the mind. So this is just an example, but if you're seeing, this is related to every industry. We need to understand the demand so that we prepare ourselves. So there could be a lot of back end things which are to be done. For example, if I take an example of a car, you might have to talk to all the suppliers who will be providing the car parts. You have to ensure that the assembly lines are proper, you are creating that car right in time, and all that stuff. So for that, most of the industries do descriptive analytics to identify the current demand, current analysis, current stage, current trend, and so on. And transactional data is the prime for that descriptive analytics. So we were just understanding that in initial years, we used to directly run your queries, but later years, people thought that because the queries are hitting your SLAs, we want to shift that onto the night time. And you might have heard, like if you are also having good amount of experience, you might have been working in such kind of areas where these batch jobs are running in the night. So these night jobs used to run entire morning, nothing is happening. In the night, these jobs run. In the early morning, people used to create reports and all that stuff. And then slowly it shifted. That also used to cause problem because companies have went global, right? So if company is only working in one geography, say in India or in US or in Australia, and if it is only working in that geography in the morning till evening, then it is good. But because of the advancements of internet, availability of online transactional processing and other things, people are no longer going to shops and doing other stuff. So they are able to transact in the night also. So that also created problems that instead of running our transactions in the night, what people did is, let us create another area, right? So that people called as data warehousing. So what they did is, our operational data stores, which are storing a lot of transactional data, that is kept aside, and then we have kept a new particular area which is called as data warehousing, where we try to copy your data from your transactional data to the data warehouses and then do the processing, right? So I'm just trying to give a kind of brief overview of how things change. And from data warehouses, they used to be, it is a very, very cool area. Many people have experience and so many years of experience on doing that, doing a lot of data transformation, trying to do data analysis, all that things used to happen there, used to create reporting and all those things. And then after that, people, because there are new data areas coming up. For example, we'll discuss that now data is no longer in a in a row column format. Okay, row column format in sense, first row is a integer, second row is a string, third row is a double, like that. In a table format, most of the data used to be there in a table format. Nowadays, now data is no longer in a normal row column format. We also have additional types of data, like for example, video data, image data, and so on, which did not which was not able to process in the data warehouse part. So that's the reason people now are shifting to something like data lakes, big data, cloud-based storages, and so on and so forth, right? So that is how your current stages are moving. All right, any questions here? Are we getting clarity? Right, so transactional data is something. Then other areas where the data is there, for example, and another areas like audio and experimental data. Now, audio is again a prime area of new source of data which is coming up. For example, you might have looked at our phone applications, audio applications like Siri, maybe Google Now, Cortana, or you can talk to Alexa. So what we are doing is we are technically talking to a device saying like, hey Alexa, what is the weather today? So when you're saying, hey Alexa, what is the weather today? It has to understand my language. It has to understand my language, decode it, maybe convert into a text query. For example, I want to know the weather. So it has to convert into a query and then fire it in the backend search of what is the weather today. Probably it does a Google query, and it has to come back saying that today's temperature is like say 32 degrees centigrade or something like that. Now, what we are trying to do in this kind of a processing is ability to provide a speech synthesis, understanding your speech, synthesizing that speech, decoding that speech, and then doing any queries related to that speech. Like that, identifying that speech, a lot of experiments are happening. If you remember, in the olden days, olden in sense, somewhere in the early 2010s and so on, where these newer devices were speech enabled. Like you would see iPhones and all the smartphones were speech enabled, where you can talk to them. They will do some operations like Google Translate. You could use an app, you can speak to that, and then it will try to translate in another language. So it did not used to understand, for example, special some dialects. For example, an Indian speaking in a different dialect, it used to did not used to understand. But nowadays, because there's a huge amount of data, a lot of training has happened. Even if my kid speaks to say like Google, it will be able to understand. The reason is because there's a lot of training happened, a lot of data science algorithms are being implemented, a lot of upgradation has happened. Now, why we are talking about audio data is, again, there is a movement in which people are trying to shift from a UI based applications to a no UI. Okay, and no UI in sense there will not be any UI. You will be talking to the devices. For example, you can talk to your fan, you can talk to your TV, you can talk to your refrigerator, you can talk to anything, right? In the coming years, you would see that all these devices, you would be talking as if you're talking to some person, right? So as if you talk to your spouse or a mom or a dad, you're talking to your refrigerator saying that, hey fridge, do you have enough milk? Then it should look at internal data, and then it should be responding, right? A lot of such kind of research is happening, and we are very fortunate that we are in this age where these all transformations are happening, and data science becomes the prime key of doing applications of those areas. Second one, which I want to target, is about the experimental data. Experimental data is, again, I could take an example of COVID, right? So now we are in the uh, phase of this big, pandemic and the COVID and other things. Now there are a lot of experiments happening. There are a lot of experiments happening for the vaccine, for the drug, and other things. But if you see, these experiments would require a lot of statistical correlation, right? For example, if I am trying to create a vaccine for COVID, now there are different amounts of clinical trials which happen. So there are different amounts of tests happen and different amounts of clinical trials which happen. And it would require a lot of amount of extrapolation, because the drug is not tested on every person, right? The drug is invented, but drug is not tested on every person to test the correctness of the drug, or the genuinity of the drug. So for that, what we generally do is they try to do statistical analysis. So we generally call it as inferential statistics, where we try to infer the different samples of the population. For example, we take all COVID patients and then trying to sample them into different gender, different race, ethnicity, their bodily conditions like weight, height, all those things. And then based on that, we try to collect samples. Once we collect samples, then we test the drug. So this is done by a lot of different organizations. In US, there is a team called as FDA, Food and Drug Administration or something. So they conduct all these tests for approval of a drug. And these experiments will be conducted by doing a lot of these statistical techniques, which again comes as a part of your data science. Now, data science is a big area which is combining multiple things. Now, statistical techniques or application of statistics is one sub area of data science, where we're trying to identify, because I can't test the drug on everybody. Now I want to get a sampling, which is called as inference. I get this inference from everybody and then trying to test my drug on that small sample. Like imagine there are 10,000 patients. Now out of the 10,000 patients, we take right sample and then create a sample size of 100 people and then test the drug on that 100 people. Now, once I test the drug on the 100 people, then we try to see that if it is positive or not. If it is positive, then it goes to the next stage of clinical trials. Understood? So that is what we are talking about, the experimental data here. Another important area, which is also very uh, newer area and a lot of analysis happening, is on the video and image analysis. Now, video data, it could be used in different verticals. For example, in Hyderabad, with the collaboration of IIIT Hyderabad and IIT Hyderabad, there's a lot of research work happening in identifying people who are wearing helmets and face masks, right? So, for example, you are not wearing helmet. This I know because I worked with some of the professors who are very closely working in this particular area, and with the help of Hyderabad GHMC, they were created this application where it takes the data from your traffic signals, the traffic signals live feed camera, and then it identifies whether the person is wearing helmet or not. Like if person does not wear a helmet, it tries to capture the license plate number and then tries to automatically send a challan or like a ticket to the person so that he has to pay that. A lot of these kind of applications are happening in the space of data science, like for example CCTV surveillance, identification of malicious actors or fraud detection. Such kind of things are happening. A lot of applications are being created with video and surveillance cameras. One of other project which I worked with one of the company is to identify drones. For example, these are with border security forces and all. So their requirement is very peculiar because these people are in the border and there are these drones which are coming up to take captures or pictures of the areas, identifying where all the soldiers are placed and so on. And to detect the drone, because it is flying very high in the sky, to detect their movements, it becomes very difficult, and many people have to be placed in different areas to identify whether there are drones or not. So to remove that, now people are working on creating applications which is taking the help of high capacity surveillance cameras, and they would take the videos of your border, and if they have identified the drones in the sky, then they will try to alarm the personnel and they would try to take necessary action for that. So such kind of projects are being created with the help of video data, and these are a couple of them. We will be talking a lot of applications, but these are a couple of them which are in this particular space. Now coming to the image data is having huge application areas. Like if you have you've seen Google I/O's last year and before last year's speech, Sundar Pichai was talking about diabetic retinopathy. Diabetic retinopathy is something like a very common in India, that people having diabetes, right? The healthcare is very weak in India, and unless until they lose their eyesight, people will not bother. And this is, I'm talking about villages and other areas, right? And nowadays people are getting very habituated of getting some tests done and so on, but that culture is not there in the country. So what happens in villages is that people, if they have diabetes, they will slowly lose the eyesight, and after a few years they will become blind. Slowly their eyesight will be deteriorating, and after a few years they will lose the eyesight, like as they get old. They think that there's something, some word for that, and because of that, due to the age they're getting it, but the reason is because the diabetes in the body is affecting that. And Google has created an application with a combination of Arvind Eye Hospitals and Shankar Netralaya. There is the product called as Verily, and which uses image-based processing to do something called as diabetic retinopathy identification. So it tries to take the pictures of your retinal scans and then uses the pictures of the retinal scans to identify whether the person has diabetes or not. And when you see this diabetic pictures, right, the retinal scans, you would see that in the eyes, there will be like small spots which will be formed, like cotton spots, small cotton spots. Those are being identified to check whether the person is having diabetes or not. And if the person is noted that the spots are having diabetes, then using that information you can detect early detection of the images, early detection of the disease, and then a lot of treatment can be done in a very early stage so that people don't get the diabetes. Understood? So those are very cool application areas, which again, using data science, deep learning, machine learning, different technologies, they are trying to build these applications. Another interesting areas is the different charts and graphs and stats. Now, this is also a part of data science where we are looking at different charts, creating some reports, able to draw some patterns, because you might have heard this, that picture is worth than picture is more worth than 1,000 words, right? If you're able to depict your entire data process or data analysis in terms of a picture, it gives a lot of edge to the way the data analysis is happening. And that is the reason a lot of reporting companies which are very getting popular, and data analysis is all about combining all these different areas into one single application. So it is combining your data process, it is combining your algorithmic process and visualization process. So in the end, you will be combining with a lot of these visualization tools. Some of the popular tools like Tableau, Power BI, MicroStrategy, ClickView. These are all some of the popular tools which are there in the market, which will be combined with a lot of data science applications to provide quick insights in terms of graphs, charts, statistics, and so on, to show like what is happening in the data. Imagine I give a full table of information about some car sales. If I give a full table of information regarding how many cars were sold in so and so areas and so on, it becomes very difficult for a normal person to read. Instead of that, if you give in the same thing in terms of some charts, you would see that there is a plenty of analysis which could be derived from understanding those charts. So that is the focus here. So data science also have these different data types in terms of graph, charts, and stats, where we can use this pictorial representation. Yeah, somebody is asking pictorial representation. Yes. So representing your data in the form of some pictures or graphs and so on. All right. Any questions so far? Are we any questions? I would like to take a small break in sense and just want to have some water. But if you have any questions, please ask me. If you don't have any questions, it is okay. But if you have any questions, you can post. We can discuss in a brief. All right. So let me continue. Here, so we will be discussing about the artificial intelligence, machine learning, and deep learning. So there is a question that in video analysis, the object will be moving, right? So how to identify that? So if you request everybody to go on mute, please. If you don't have any questions, request to go on mute. Show somebody. Just a second. Saraswati madam, request you to go on mute. Organizers, you guys are there?
Yes, sir. Yes, sir.
Can you mute everybody? I think there is an option from your side, right? Can you mute everyone?
Yes, yes, I'm doing that.
Yeah. Okay. So there is a question that if the video is there, there will be objects and the objects would be moving, right? But the way it works is, Saraswati madam, request you guys to go on mute, please. All right. Thank you. So what I was talking is, imagine the question is that if I'm taking a video, the objects will be moving in the video. How do we identify? That is a question. The thing, the analysis, the way it is done is the videos will be having frames. So you will convert every video into internal frames. So you might have heard like 30 frames per second, 60 frames per second. Movies will have 24 frames per second, right? So those are different frames which will be forming your video. Technically, it is like nothing but, I'm not sure, but in my kid time, there used to be a book where your Saurav Ganguly used to, uh, a book, if I run the pages, it would see like as if Saurav Ganguly is, bowling, and then or Saurav Ganguly is hitting F6 or somebody is bowling, right? The way it works is all the frames connected together will be running as a video. So when you really work on videos, what happens is you come down to the frames and then you do the analysis, right? So even if you come down to the frame, it is a still frame. That is how it works, right? I think somebody has answered. Yeah, Prithvi Sai video is taken in terms of frames. Yeah, exactly correct. So how visualization tools are playing a role in data analytics? It's a good question again. So I was talking about the visualization is taking a very important role in terms of, there are two important areas where visualization tools help. First one is doing something we call it as exploratory data analysis. Exploratory data analysis is nothing but understanding my data. Imagine I have 100 rows of information. I got a CSV file from business, maybe like a bank business. The bank is giving me a CSV file for understanding whether a person has to be given loan or not. Okay, so that is the analysis. They have collected this information for past 3-4 years, and they've created a very nice CSV file with 100 columns in it, or 100 features we call. Now, out of the 100 columns, which one are important, which one are not important, which can be removed, what we call as value added and non-value added columns. Now all these analysis has to be done, and in that also we have to see like which of the columns are very high correlated, which of the columns are very low correlation. In the correlation also, if they are linearly correlated or linearly negatively correlated. So there are a lot of these questions which has to be answered. If I just look at the numbers, there is no way of understanding all that stuff. So what we do is we do something called as exploratory data analysis, where we try to project some graphs of your input data, some input columns. You try to project graphs in terms of column A, column B, X, Y, Z. Likewise, we try to draw some graphs between the data. If you take real data, I would say like bank application, my real data could be what is the salary of the person, what is the bank balance of the person, whether he is married or not, right? His marital status, married, widowed, divorced, single, right? This could be different statuses. Likewise, there could be 10, 100 different columns which will be there. When I'm trying to extrapolate this data in terms of graphs, in for example visualization, we try to identify which are good columns, which are not related, which are having no correlation, the data which is having missing values, data which is having high influential parameters, and so on. Basically, doing all that stuff, we can come back to our analysis. So that is the first angle. Before we get into any modeling, we will do something called as exploratory data analysis. And then after doing the modeling, we also use visualization tools to showcase the results. For example, I created a model. I want to showcase the results in terms of what is the accuracy, what is the prediction ability, how well the model is being predicting. All those things will be known after we provide my model. After we do the analysis, I want to showcase the results. For that also we use visualization. There are a lot of visualization tools internal to data science. Also there are a lot of tools like Matplotlib, Tab, your Seaborn, you have Bokeh, you have different other libraries like Plotly and so on. We could use all those libraries for doing data analysis. Apart from that, there are third-party tools also. For example, Tableau is there. You have Power BI is there. You have MicroStrategy, ClickView, as I was saying. Those are all are very, very important. All right. So yeah, so I see that a lot of interactiveness is happening in the chat. I request people to ask questions and we will do it as an interactive session. So this is not like a college course where I'm telling and then you are listening. So this is like you are spending one nice evening understanding the technologies, identifying where the trend is going, how things are happening. So that is primarily the goal. So I would like to give as much as information from my side. I would like you guys also to be as responsive, and you can ask questions. We can, if you already know the information, you can, respond that also, right? So coming back to your three important areas, and this is very super hyped areas. Okay, now people I give this kind of thing. In Hyderabad there is a place called as Amirpet, and then people have these banners across your boards and banners and all of that, and they say that 10 years on experience in artificial intelligence, 20 years experience in artificial intelligence, 30 years experience in deep learning. Okay, the moment the technology would come out, you would say 30 years experience in deep learning. Okay, and there is a super duper hype in the understanding these terms and identifying the differences in the places and applications, or how they are related, because you would see that you would see AI, data science, machine learning, deep learning, and these all different terms are used. So if you know about this, this is great. But if you don't know, I would like to put a little light on this. So artificial intelligence is more of a umbrella area of machine learning and deep learning. Or this particular diagram shows that. So what artificial intelligence does is it applies a lot of logic and rules to do a certain thing. In fact, artificial intelligence is very old thing. We were starting discussing that many years back. People started creating algorithms about artificial intelligence and so on. It is a very old thing, but what we are trying to see is we are trying to create an application. For example, it is trying to mimic the way humans are behaving, right? We are trying to create a set of rules in which the humans do the work, and instead of human doing that work, we are trying to create that rules and processes and tools and decision making analysis for machines to do that. For example, let me take an example. If I'm trying to create a machine which can fold a cotton box, okay, so you have a cardboard and then you're trying to fold it into a box, and if a person is doing, then he's doing this folding in a certain way. So he takes the left fold, right fold, then folds that cardboard into a box, and then creates it as a output. That is how it is as an output. But if I want my computer to do it, if I want to computer to do that folding, like a robotic arm doing that folding, then I have to give a certain set of rules to that, right? So if you're trying to give a certain set of rules, like, okay, first do the first fold, then do the second fold, then turn the box, then do the third fold, like that, these set of rules which are governing the actual process is called as artificial intelligence. So artificial intelligence is trying to make machines do the same work of humans, right? So it basically creates applications in which we're trying to make machines do the work of what humans do. So you can say that this is like robotic process automation, a lot of automation related tool, all those things which are currently right now in the space, those are what we can call as artificial intelligence. Okay, now artificial intelligence have other deeper areas, for example machine learning and deep learning. Now in machine learning, what happens is, now you are setting the rules in artificial intelligence. Artificial intelligence, we have to set those rules. You have to say like, okay, if this is happening, do this. If this is happening, do that. Like if then else kind of a loop. But if in machine learning, what happens is we are trying to use some statistical techniques. So we are giving a bunch of data points to your machine, and then machine is trying to identify what is the pattern in the data, what is the relation in the data, and then based on the relation, it tries to construct some statistical model. Okay, now this terms could be very, very heavy for somebody who has not known anything, but I'm trying to make it as simple as possible, telling that machine has an ability to understand data. Machine will have an ability to understand data, construct some kind of formula of that understanding. Okay, it looks at the data, some 1,000 records, 10,000 records, it is looking at the data, and it is trying to make sense of the data and trying to create an understanding of your data, and then derive a formula. Just say derive a formula which is having some relation of input and output, and using the formula it tries to make some decisions, right? Imagine the bank example I'm giving some 10,000 bank records of past 3 years, and then using that bank records I want machine to automatically uh, provide an ability to approve a loan or not. Okay, so we have already provided the data before, and we want to see that, looking at the data, I want to see that how I can create an automated application which can say that, if the age is greater than so and so, if the salary is greater than so and so, if you have enough amount, this much amount of bank balance, and if you are married and all these things, you will get a loan. If something other pattern, you would not get a loan. That has to be automatically done by the machine, which is called as machine learning. Is it clear, guys? The second part is where your statistical models are coming into place. They are trying to identify the data, they're trying to identify the pattern, and then coming up with a decision making to give your options. The third area, which is again a subset of artificial intelligence and machine learning, it's called as deep learning. Now, deep learning is very crazy. From the past few years, 2017 onwards, 2017, Google has released a model called as TensorFlow. TensorFlow has become so popular that it is an open source deep learning library or framework, which provides a lot of models which can do understanding of data. You could do very, very crucial tasks like speech recognition, image recognition, and so on, using some models like neural networks and so on. But here we have gone a one step advance of using the same machine learning models for doing applications which are related to images, speech, sensor data, maybe like textual information, natural language processing, and so on and so forth. A lot of those areas which are very, very data intensive. So you will be having image data, you will be having video data, some temperature sensor from a particular sensor. All those data is very, very different from a regular row column data, right? From a regular database data, it is very, very different. So such kind of data, applying the same machine learning techniques using some neural network processings, can be done using something called as deep learning. Now this is all linked, everything is linked. Now people can ask a big question that, sir, this is all okay. Artificial intelligence, machine learning, deep learning, everything is good. Then what is data science, right? So the data science is an interlinked area of all these three things. If you're looking very closely, that these areas are very technically involved. So machine learning, deep learning, these are all algorithms or at least rules. These are very, very technically involved. But data science is more a business process. If a business, if a banker, if a, say like a bank manager or somebody higher up in the bank wanted to create a process of automatically identifying who will be taking their term deposits, now that is a question, as a business question. Now when that business question comes, now what all things to be done in place so that you can create that final end product is what is the data science. Like, how do I collect data, what data to be collected, what data to be processed, then what machine learning algorithm to be applied, how to build a model out of your machine learning algorithm, where to deploy the model, how to ensure that the entire pipeline is created in a process so that every time there is a new data coming up, new learning is happening, a new prediction is happening. All those things are very, very involved. So when you see from head till tail, the entire process life cycle, it can be defined as data science. Are we getting it, guys? Now we are getting. So now if you take more on a business perspective, people give this requirements in terms of data science. Now I want to do this. I want to know like how many bags of rice are being sold in the shop every week, so that I will talk to my suppliers to do the supply of the rice every week, so that my customers are receiving right quantity of rice without me storing extra bags of rice in my godown. I want to know exactly, right? Imagine in every week 140 bags of rice are sold. I want to know exactly how many bags of rice will be sold. I don't want to bring 200 bags of rice and store it in my godown. 140 bags will be sold, rest over 60 bags will be lying in the godown. I don't want that state. I also don't want to bring only 100 bags where people 40 customers will be going away from my shop without having any bag of rice. So we want to create applications which are taking our data, trying to create end-to-end processes, so that we want to create such kind of applications. That is what these all technologies will be related. Are we getting it, guys? So there are a couple of questions. Let me answer them. So there is a question that out of the various visualization tools like Tableau, Power BI, ClickView, which one is the leading one and preferred? See, I would say the leading one is Tableau, but Power BI is also picking up very, very fast. Okay, Power BI is picking up very fast because the reason is that Microsoft is very, very aggressive in targeting the clients. They're aggressive in turning out the clients. They're giving up some freebies. Office 365, they give it for free, and a lot of those tactics are there, but it is trying to gain a lot of market share, Microsoft, and that's the reason Power BI is picking up very fastly. But if you ask about the market leader, that is Tableau for visualization part. Okay, so there is another question. What all languages should I need to learn, and how to start, and where should I begin? I'm a beginner studying final year engineering electrical. So question is very important, very good. Basically, somebody who is doing engineering or maybe in the final year engineering, what I would suggest is you have to be very, very active this particular time of the year, or the time where we are right now is very crucial, and I would request everybody not to waste time, because we are going to be very, very serious in what we want to achieve, because everybody else is also in the same place and they are also very competitive. So the language which you want to learn, for example, if you want to get into the data science and this part, first one is Python. Okay, because Python is such a universal language. A lot of applications could be done. It is such a language where you can use to create websites. You could use it for creating data science models. You can create APIs. You could use it for testing. You could use it for scripting languages, doing for infrastructure management. You name it. We can use that language for everything. It is also not very hard. It doesn't depend, for example, you are an electrical engineer, mechanical or civil engineer, it doesn't matter. It is not very hard. Okay, that is very, very important. And if you spend around 1 month to 1.5 months, there are plenty of materials available, and you could be learning Python. If you learn Python, that will give a very strong base for the future things. And why I'm saying Python is because if you see in the past few years, there are a lot of these tools which are given heavy push. For example, TensorFlow in the data science space, you have PyTorch, or again from Facebook. These tools or these frameworks have actually taken Python to the next level. And Python has again a very huge developer community because everybody is implementing Python. It is an open source language and you don't have to pay. If you see startups, they're using Python for a backend framework and all those stuff. So it is actually very, very easy language and very important language. So I would say that one is very important. So start learning Python. That should give you a good base. Okay, so I have 13 years of experience and learned data science for a couple of months. Okay, so if you have learned data science, then you should target how to tap in the jobs. So one request I would do is identify the place where you are, identify the companies which are focusing on the data science part, because depending upon the place your requirements could be different. Maybe companies from banking, companies from healthcare, different areas are looking for data scientists. So you have to target that part and focus on how do you convert that into a job opportunity. Right. I'm sorry, I might be missing some of the questions, but I'm just going through different questions. So in the last example, how to understand whether the sales in the sudden pandemic, yeah. So the question is like because the pandemic can happen very rarely, and the thing is that you can also track the pandemic also. That depends upon the sentiment changes, the mood changes, and different news factors could also be considered. But that model will become very complicated. It all depends upon your data. Imagine your data is only identifying your past purchase patterns of people. Every day, imagine 2 bags of rice are being sold or 5 bags of rice are being sold. Now that is the technical purchase pattern, and if you're just concentrating on that data, this pandemics and extra things might not be considered. But imagine you're also considering the local news. Imagine you're considering the farmers feed information, for example, the crop growth, your monsoon cycles, and different other things, which also can give us a lot of extra information. If you consider all that data, then your model will become even more complicated to identify those sudden changes also, right? But the model will become very difficult, but yes, can be done. Is Java related to data science? There are some applications which Java is there, but when coming to the core data science, there are two languages which are primarily used, Python and R. Python is picking up a lot of space right now. R is slowly dying up, I would say, because it used to be very, very popular in 2012-14 time frame. But nowadays, because advancements of Python, ability to grow a lot of frameworks, the growth in the community, developer community, Python is becoming the leader. So any aerospace company hiring AI and data scientist, I exactly do not know that. I would request, depending upon the place you are in, for example, if you're in US, Boeing is a company which I know of, which have a lot of data scientist posts. If you're in India, then there are companies like Robert Bosch, which is hiring a couple of data scientists. But again, that is individual question kind of a thing, right? So if you already know a couple of things like loops and functions and strings, what should we learn after that? There are Python related data science things like NumPy, Pandas, Matplotlib, and so on, which are very important to learn. Those form under the data science area. Those things you have to learn to get into data science. There is another question that which sector is mostly into the data science in the future, which sectors are concentrated. Healthcare, yeah, somebody rightly said healthcare is very, very important. Healthcare area is there. We have banking, financial companies use data science. If you're in Hyderabad, then the companies which I know which are offering jobs are banking, a lot of banking companies. There are a lot of job opportunities. I know JP Morgan Chase has openings, Bank of America has openings, Wells Fargo. There is another banking company in Hyderabad which has openings. So those are areas which are focusing on those spaces. In fact, in healthcare side also, there are a couple of companies in Hyderabad which are having openings, and Novartis has opening in Hyderabad for data scientists. So these are some of the companies which I know which are looking for data science professionals. But that is case on case basis, depends upon your experience, the ability to articulate your experience, the previous working experience, all those things come into the place, right? So you need to be prepared for that. What about telecommunications domain? Say, I'm not particularly talking about one area, but there are plenty of areas in telecommunication space. Again, in Hyderabad, if you're asking, there are two companies which I know of who are hiring professionals. One is Qualcomm, and second one is Zilink, which is hiring people in that space. Yeah. Any significant role of data science in being involved for finding medicine in COVID? In fact, there is one university which is exactly working on that particular domain. For example, John Hopkins University is there, which is working, trying to make use of data science for identifying patterns in COVID and identifying patterns in the COVID this thing. They're not drug company, but they are trying to use data science to give a lot of meaningful insights. They are also giving advices to World Health Organization, John Hopkins University. Okay, that is a university which is doing that work. They also provides a lot of reports, patterns, and other stuff. So Naveen Sai, the question is like, loops, functions, and strings. The other things which you need to know is pandas, numpy. Yeah, I was just telling about that. Pandas, numpy, matplotlib, seaborn, those are data science related libraries. There are libraries like scikit-learn, TensorFlow, PyTorch, Keras. Now I can talk about a lot of those, but these are some of the ones which you need to start. Yeah. Gaussian has responded, pandas, numpy, matplotlib, and seaborn. Exactly. All right. Can you provide feedback on the enterprise software like IBM, SPSS, and SAS? They are very popular. They are huge base of customers. But as I know, some of the people who were having their shop in SAS, they are shifting to Python because SAS is a proprietary software and they have to give a lot of money to the licensing and yearly cost, and a lot of those things are there. So slowly they are shifting towards Python based tools because the ability to do coding and a lot of those things are there. And one more other problem is that there is a reduction in the skill sets in those technologies also. So that is also creating a lot of problem, right? Right. So whether non-IT professional can take up data science, it would depend upon the application area where you're working, how you want to deal that. I would say anybody can take up the data science, only that you have to be focusing on what would be your nature of work. If you're completely non-IT, you don't know anything, any language, then I would suggest that you have to start from very basics. But the job opportunities are there. There are a lot of job opportunities, but you need to ensure that you have that amount of ability to use your skill set. Either it could be domain skill, you can be analytical capabilities and other stuff. Use those skills for getting a job. So that is how the transition should be. So there's another question, interesting question. What is the difference between data scientist and artificial intelligence engineer? Again, I was saying there are fancy names. So we will discuss about very deeply tomorrow, because in tomorrow's class I will be talking about these job roles, very clear differentiations between the job roles and so on. But if you broadly take, data scientist creates these models. He's the one who is creating the models, deep learning models, identifying data, doing the pre-processing of the data. All those things will be done by the data scientist. And your artificial intelligence engineer, or you can also call it as machine learning engineer, is the one who will be dealing with productionizing the applications. Because you create this model, you do data analysis, you create the model, you have to productionize this, right? Productionize means you have to take it into the live world. Now, how do I build an application? How does my front end web application call my model? What are the parameters to be passed? How the invocation will be? How do we create the APIs so that those can be invoked? All those things have to be done so that your product is end to end. So for that, you would require the help of artificial intelligence engineer, or ML engineers we call. Right? Those will be the ones who would be doing this, who would be using this process. So there is an so what is the use of Keras CPU, and PyTorch? They are used for deep learning models. For example, identifying image-based processing, speech text recognition, all those things could be done by that. Yeah, let us take a small break here. Let me take what's the time right now? So I wanted to give a small break, and that's the reason I took these questions, because I don't want to stop the flow. Is it okay? Can we take a small break here? What's the time right now? 7:30. It's in the middle of the class. All right, so we will take a small break, a quick 5 minutes break. Organizers, can we take a break right now? I just was trying to answer some questions, but a lot of questions are being poured in. We will take a small break. I'll continue the course, and maybe in the end, we will take some more questions. All right. So my time right now is 7:37. What? 7:28 IST. We'll take a quick 10-minute break, and then we'll come back. We will have this session at another 1.5 hours. So please bear with me. If you have questions, keep it with you. Definitely we'll answer. I will answer every question. And this is 2 days workshop. So we will also have a session tomorrow. There are a lot of topics I will be covering on the roles and responsibilities, different areas, how to get a job. Those things we will cover. If you have those general questions, we could answer them. But if you have any technical questions related to whatever I'm discussing, please ask. Okay. And please bear with me, okay? People who are asking the question will have a different perspective. People who are listening to the session would have a different perspective. And it is always difficult to match everybody's expectations, right? So please bear with me. We'll take a quick 5-minute, 10-minute break, 7:30 my time. We'll regroup at 7:40. All right. All right, friends, we'll start the next part of the session. Thank you for patiently waiting. So can I get a quick message that we guys are ready? Yes, perfect. Thank you. I like the enthusiasm. So what we will learn now is understanding about different application areas. So this will give a clear understanding of data science and how it is used, which applications it is used, and all that stuff. One primary application area which I would tell that this is a base for all the data science, data related applications is social media analytics. Now, what is social media analytics? You might know all these apps, Google, Facebook, YouTube, LinkedIn, Instagram, all these companies, they had a peculiar problem which was not solved before. All the companies before these are having data stored in proper tables. Like data analysis was done in proper tables. With the advancements of these companies, they have new data problems which are created. For example, data stored in terms of index documents, right? Google, if you see, it does a lot of indexing of document. We have to do a faster search processing, faster query, and data recognition, search, and other things are very difficult for that company. Similarly, if you're looking at any other social media company, you're trying to look at Facebook, you're trying to identify recommendations, friends-based recommendations, and so on. YouTube, you would see video recommendations, and you could take Instagram or LinkedIn, and I think any other particular company. They're working on all these areas. In fact, they have also become pioneers in bringing up a lot of open source tools. Now, I was just talking about TensorFlow, which was released by Google. TensorFlow was used with a lot of internal tools of Google. For example, Google Translate uses TensorFlow, Google Photos uses TensorFlow, YouTube uses TensorFlow. Like that, it was used in a lot of their proprietary products, but was later released as an open source, which has given boost for a lot of regular companies to use those tools and create very meaningful applications. And that's how the data science as a trend has picked up pace since 2016-17 timeframe, because these all open sources were created, which has created a very big difference. So I would say these companies are pioneers in getting all these applications into the space. Another application area which actually picked up right after the social media companies have released all these tools is the predictive analytics. Now, what is predictive analytics? Predictive analytics talks about predicting what is going to happen in the future, which is very difficult. As I am trying to show this, parrot trying to pick up a card and then trying to give the prediction. It is very difficult tasks because there are many moving parts to it, and but that is also very important. Predictive analytics provide us an ability to forecast things, right? As if I want to know like how many cards Maruti is going to sell in the month of July. Maruti card, how many cards it is going to sell in the month of July. That is a very important question for higher management of Maruti, because they need to know if they have to sell, they have so much demand, if they have to sell so many cars, they have to keep the cars ready, right? So they have to procure all the basic parts, they have to procure all the components, they have to do the assembly lines and all those things. They have to ensure that all these things are in place. So for that, predictive analytics becomes very important. We were discussing about descriptive analytics, which is describing your data. It means that whatever already happened. So describing whatever has already happened is called as descriptive analytics, which gives us stats in the terms of numbers. What are the average price? What is the average profitability of the company? Number of products sold? All those things are coming into the descriptive statistics part, whereas the predictive statistics part is predictive analytics part is talking about futuristic thing, like what is going to happen in the future. There are a lot of these linked things which is contributing towards the future, so we can forecast these future things, and then we can use that for the analysis. Now, a lot of other companies which are picked up predictive analytics right after the boom of all the social media companies are these banking and financial companies. So I was talking about these prime banks which are doing a lot of this analysis, is to identify who are the customers, who are the potential customers who can take loan, right? So banks works because they take money from the the customers and then trying to lend it to the potential people who want to avail loans. Now they want to identify who are willing to take loan, and what is the likelihood or the risk potential of the customer, like what are the current liabilities, current assets, the different other loans he has. All those things we are trying to, based on that we are trying to predict a future risk appetite or risk potential of that particular person, and based on that we are trying to predict whether we should give a loan to that person or not. Such kind of applications are being built, and a lot of those things are helping in creating a futuristic stuff, and data science is very core in building all these applications. Our next important application area, which is very important, is called as fraud and intruder detection. Fraud and intruder detection creates a lot of these application areas where we are trying to identify fraudulent transactions and identifying any intruders. And again, the areas which started applications in this are financial companies and insurance companies. They claim insurance claim related stuff and so on. So mostly financial domain companies and some of the telecommunication. Is there a question? If not, request to go on mute. So fraud and intruder detection are the application areas, next application areas, which are trying to identify these fraudulent transactions which are happening. Now, if you're looking at a bank example, now you are a regular person, you are regularly buying some groceries, you go to maybe once in a week you go to movies, once in a week probably you go to some restaurants, you eat outside, and your life cycle is like simple and very plain. You regularly buy some groceries, goes to shopping, buy some clothes and these things. That is your regular lifestyle. Imagine you suddenly buy a 4K television, right? So your regular lifestyle is like a normal person who is purchasing some basic groceries, basic lifestyle needs, and once in a while going outside, eating food outside or movies and so on. Well, this is your regular lifestyle. But imagine you purchase a 4K television. So suddenly you get these intimations that sir, we have seen say like 2 lakh transaction on your credit card or a debit card. Can you authorize whether is this you? Can you confirm that is this you? Right? You might be getting it right. Nowadays we are linking with a high security system like OTPs and so on. But if you go backwards like 5 years or 10 years backwards, you are not having these OTP systems where you could use your credit debit cards just like that, and you used to get these kind of alerts on your high spend transactions. The way these things were happening was trying to do something called as anomaly detection. The technique in the data science which will be used to identify these kind of fraudulent transactions is called as anomaly detection. We're trying to find anomalies from a group of transactions. A lot of transactions, when you keep together, you try to identify these anomalies. Anomalies are what? Those are the transactions which are not behaving like your regular group of transactions. As I was telling, a person who is doing regular spending like in shops or maybe movie theaters, once in a while restaurant, this is his or her spending pattern. If he suddenly buys a 2 lakh television, then that is an anomaly. Are you understanding? So anomaly detection is a technical concept in which we are trying to identify these we also call the name as outliers. We identify these outliers who are very different from your regular transactions, and you try to identify that how these transactions are different from your exact group, and then you keep it separate first, right? So you try to separate your regular transactions from the anomalies, and then try to do a specific process to those anomalies. So what could be the specific process? You could be sending emails to them, or probably you will be alerting the voice call center professional to call the person, right? You might be blocking their card also. Sometimes, you do similar kind of transactions. You suddenly went out to a holiday trip to Singapore or maybe Thailand or any other country, and you did not intimate your banker, and then you spend your credit card there. You could see that there is a sudden blockage in your card. All those things are linked. Basically, there are algorithms which are working in the back end or real time, and then they use data science related algorithms to identify the frauds and intruders. And using the fraud and intruder detection techniques, we try to identify whether this particular transaction is fraudulent or not, whether it is an anomaly or not. And if it is an anomaly, then there are certain businesses process which will be considered to be done. Next application area is sentiment analysis. Sentiment analysis is also very widely used in data science, where we are trying to use something called as natural language processing to identify sentiments of the user. Now, sentiment of the user is again, it's a very general concept. Now we are trying to identify sentiments of the user. We are trying to say like whether this particular comment is a positive comment or a negative comment or a neutral comment. Now that is a very simple thing. I used to work on a project back in 2010 for a US car rental company, and back in those days we did not used to have so much of web presence, and so they used to have this web portal called as a voice of the customer portal. The voice of the customer portal, what the purpose is, they used to gather all the feedback of the customers, and the project was to identify the feedbacks and to provide sentiment score based on the car rental location. So these are car rental locations in US, where they basically rent cars in airports and primary places. Car rental stations will be there, and you go there. For example, you get down in New York JFK airport and you rent the car. You take out, imagine you came there for a couple of days vacation, so you rent out the car from the airport, you go around the places and then in and around New York, and then return back the car in the airport, and then you fly back. So that's how your general purpose would be. And what we want to do was these voice of the customer portals was there, where people can provide feedback about their experience. For example, how was the experience of the car? Was the car neat? How was the experience of the agent? For example, the rental agent, the overall experience of your renting out process. So all those things, there were different points. Based on that, the feedback was selected, and the purpose of that application was to identify, uh, what is the sentiment of the entire transaction, what is the sentiment of your entire process, and we have to give it based on the location. So out of whichever has best sentiment, they will be awarded with location of the month or things like that. Okay. So the purpose what we used is, in those days we used a simple NLP, natural language processing based sentiment analysis, where we grouped out the sentiments and identified whether it is a positive, negative or neutral. But nowadays the sentiment analysis is like, you have gone leaps and bounds. Now we don't want just positive or neutral or negative. In old days we used to have that. Nowadays we want to do something like entity based sentiment analysis. Now entity based sentiment analysis goes into your comment, it goes into the details of the comment, identify the entity areas of the comment, and then give rating according to that entity, right? So for example, you are going to buy a mobile on Amazon, and then you watch these reviews, right? Typically what we do, we go watch the review ratings and then go read the reviews, identify how the product is, and then you try to take a decision whether you would like to buy the product or not. So what people are doing right now is trying to do entity level, natural language sentiment analysis. So what that does is, if you have a comment, for example, let me take a comment. You are trying to buy a mobile, and the comment in the mobile says that the product, the build quality of the mobile is great, the look and feel of the mobile is great, and the battery backup is great. It would give 2 days of battery backup. It takes crisp pictures, like that. The comment goes like this, but in the end, it says that the front facing camera is very bad. Imagine the 4-5 comments, 4-5 parts of the comment, and all those things says good about the mobile. So the build quality is good, the battery backup is good, look and feel of the mobile is good, back facing camera or the primary main camera is good, takes crisp pictures, but your front facing camera is very bad. Okay, so if you are a person who is trying to buy that mobile, what is your thought? Would you buy a mobile, that kind of a mobile, or not? Can you put it in the chat window? I would like to see. Would you like to buy such mobile where it has some good qualities and one front-facing camera is very bad, say like a 1 megapixel camera? So would you like to buy that mobile or not? Right, so there are different preferences, right? So generally, so if the front facing camera is bad, if at all, I am a person who is like a selfie freak, so I would like to buy a mobile which is having a good front facing camera. So that is my preference, right? So generally I might not buy a mobile, but if I want to have this kind of a general understanding of what people are liking and what should be changed in the mobile, what we do is we do an entity level sentiment analysis. So we do sentiment analysis pertaining to the entity. So what are entities? Entities are front-facing camera, back-facing camera, battery backup. You can name it, right? So we try to do these, identify the entities within the data, and then try to associate sentiment pertaining to the entity. Now, what will it give? It will give clear-cut, pinpointed information both for the customer and also for the manufacturer. So from a customer perspective, it clearly gives that everything else is great, but the front-facing camera is not great. So this would give a clear understanding. Imagine my father wants to buy this mobile. So he is not worried about front-facing camera. He's not going to take selfies. He's only worried about the battery backup and the lifetime of the mobile, the bulk, the standard, or the what I would say, the build quality of the mobile. So these are some things he's worried about. So he would look at those angles. But imagine my cousin or my brother or somebody who's young, going college, who is a selfie freak, who wants to buy that mobile. He would not do that. So from a customer perspective, it gives a very clear understanding of what is good and what is bad. From a manufacturing perspective, also it gives a very clear understanding. Imagine people are not buying that mobile. From a manufacturing perspective, we get a clear understanding that because the front facing camera is not good, people are not buying it. So if you upgrade the front facing camera to say like 25 megapixel front facing camera, right, and you give a marketing campaign that this is a newer version, so it becomes an S version. So you get a Samsung 20 model, and then the next model will be Samsung 20S. So that S model will be having the higher megapixel camera, and it will be a super duper hit. Right? So from a customer perspective and from a manufacturer perspective, we get a very clear cut, pinpointed information: what is good, what is bad. So it will help both parties to make meaningful decisions. And sentiment analysis is used widely in all the e-commerce portals. Okay, so if you name any of the e-commerce portal which is doing customer purchase and sales and so on, you're trying to see that sentiment analysis is there in the back part. You take all the e-commerce companies, product companies, say like grocery stores, clothing stores, all those things have the sentiment analysis in the backend. Another interesting area which is kind of having a lot of space is the self-driving cars. And this uses a very important area of machine learning, which is called as reinforcement learning. And reinforcement learning is something where we are trying to give a feedback mechanism to the models, where it can take some meaningful decisions based on rewards and penalties. Okay, so self-driving cars, we might have already known. For example, Tesla is there. So Tesla is a self-driving car which is running on the roads. So if you imagine what are all the data points which are going to this particular car, you can think like there are hundreds and hundreds of data points. For example, there could be proximity sensors in the cars which can identify the nearness of the vehicles. There could be 360-degree cameras which is looking at all the cars nearby. There could be braking sensors, acceleration sensors, there could be steering wheel sensors. All those things are connected to a centralized system which is trying to feed all these data, and then based on the data it tries to take meaningful decisions. Now what are the decisions? Here we use something called as reinforcement learning techniques. Now reinforcement learning techniques apply the feedback mechanism. Imagine that Tesla car is going on the road. If it sees the signal, traffic signal, and if it doesn't stop at the traffic signal, it overtakes the traffic signal and then overtakes the line and then crosses and stops. Then what happens is you see that this overtaking is happening. The reinforcement learning algorithm, what it will do is it will try to penalize the model. Penalize the model in sense it will try to penalize in such a way that next time the model will try to avoid that error. So if a self-driving car sees a red signal, it should stop. That is the expected behavior. If it is not doing that, if it is deviating by some margin, you try to estimate the margin and then trying to penalize the model. Penalizing means you try to give negative points to the model, and if that will actually you correct the model in the future steps. So next time, whenever it is seeing the same signal, it tries to stop at a particular place. Got it? So that's how you are trying to build your application. Next application areas, classification and clustering techniques. So classification and clustering are the techniques of your machine learning, in which specific area is supervised machine learning, in which we are trying to identify the classes or groups of your customers. So you're trying to classify your data into one or the other categories, where you're trying to say that, okay, so classification problems could be, imagine you are looking at a retinal scan of a diabetic patient, and then you're trying to identify whether the particular retinal scan is diabetic retinopathy or not. So that is the classification example. You're trying to look at a lot of health record of a patient, and then you're trying to identify whether the patient is cancerous or not, whether there is a malignancy or not. So these are all belonging to classification. You're trying to look at the application of a H-1B visa candidate, and then you're trying to classify whether the visa is approved, rejected, denied, or withheld. So different categories could be there. So we're trying to identify what are the different categories of that. So that belongs to the classification case. Whereas clustering is another machine learning technique which we are trying to group all your data. So grouping of the data could be done using some technique called as clustering. There are different other techniques which are involved in that. K-means clustering, hierarchical clustering, DB-scan, and so on. You name it, there are a lot of those clustering techniques. And what these techniques will do is they try to cluster your data, group your data into different buckets. Now I want to identify customer spending patterns. Now how do I group all the customers in the spending patterns? So you can group all those people in a similar place, and then you try to identify their similarity. So that could be done by clustering. Another interesting areas are recommendation engines. Now, recommendation engines are also very popular. You might have seen in a lot of e-commerce areas and so on. So we are trying to see that if a product is having a higher association. So internal algorithms which are used for doing recommendation engines are called as association rule mining. Association rule mining is nothing but you're trying to find products and then try to find associations of the products. Now, if I find the associations of the product and then I know that product A and product B are very highly associated, then I can say that people who are buying a product A also have a high likelihood of buying a product B, right? So that is a kind of a recommendation. We say that people who are buying this particular book also have a high likelihood of buying this other book. People who are buying this mobile also buy this scratch guard or case and so on. You get these recommendations, right? Whenever you're trying to buy mobiles or anything related, you're trying to get these kind of recommendations. The way those recommendations are coming are by applying the algorithms which deal with trying to find associations between the product. And when we know these associations, we know that these related things are associated. You could do a lot of things. Now, for example, you could do recommendations. You could also do something like combo offers. Okay, you know that toothpaste and toothbrush are associated. Based on your analysis, data analysis, you see that everybody who is buying toothpaste most likely they're also buying toothbrush. And if you know those associations, you can combine those products and then give it as a combo offers, right? A lot of these combo offers are derived from these association analysis only. Now you say buy a toothpaste and get the toothbrush for 50% off. When you're getting this kind of combo offers, like a general person, you will be very excited. You will say that anyway, if you don't need the toothbrush right now, you'll still buy that because you're getting the toothbrush for 50% off. And anyway, after a month, you might require the toothbrush, so you're okay, right? You buy that. So the way these techniques are used, association rule mining techniques are used, is that they're trying to bring in these relations between the data points or relation between the products and identifying those relations and using them for a lot of recommendations. Getting it, guys? Are we understanding? Another important area, I would say, it's like the transportation and the car sharing industry. So we are looking at another important example. For example, Uber. Uber has a lot of data analysis work which is being done, right from your search pricing, right from identification of next customers, driver's help, and all those things will be driven by data science based projects. And for example, you see there is a search pricing happening, right? How does the search pricing happen, right? If you're trying to book a car, if you remember in olden days, used to have this search pricing represented in terms of 2x, 1x, 1.5x, and so on, right? Where that actually had a negative impact on the company, and they removed that particular process and then kept a newer process. If you know that the price of that particular ride is 100 rupees, and then you're giving the search pricing the 2x or 1.5x, you have this tendency that you're almost paying double price for the same ride, right? So that was having a huge psychological impact, and they have removed that. And basically the search pricing happens by simply frequency counting. So it's called as word frequency counting or transactional frequency analysis, where we are trying to identify by location, by time, by place, the surge in the frequency of the transactions or bookings or requests. If that is happening, then what I can say is that at that time there are a lot of transactions happening, so that we can implement a surge, and the surge is directly proportional to the frequency of the transactions. Imagine every day in the evening in a financial district, say like IT companies are there, every day in the evening car booking is happening, right? Say like 5 o'clock or 6 o'clock car bookings are happening. Then based on that past data, what we can analyze is we can say that at this point of the day, this point of the time, this location, there is a high search happening, and whenever the time comes, we can implement the search process so that anybody who's trying to book the car instead of showing them 100 rupees, now we can show 120, 150, 200 rupees. And because people think that, okay, this is the price, and because a lot of other cards are there, they will try to immediately book. The same thing happens whenever you get down in a railway station or in an airport. You get on the flight, you suddenly try to book a car, your search prices will be high. But if you stay calm, do a meditation, sit somewhere, and then after 5 minutes or 10 minutes, you try to book a car, I will bet that you will get almost like 20-30% discount than whatever you are showing at the first initial step, right? I back tested this many times. You get down a train, I will say that let's relax, let everybody go, and then after 10 minutes you book a cab, you get a very low price, right? The same is the case with the flight also, right? Right after the flight comes, you see that there are a lot of bookings happening. And the case is different. If a lot of flights are coming, then it's a different case. But that is generally absurd. That is done because of this surge pricing. And one other interesting area which Uber implements is using the data points of your drivers. For example, a cab driver has to drive through the area, and he has to find his next customer. So what Uber does is it identifies something called as hotspots. So if the Uber driver can call the Uber center saying that, I am done with the ride, I would like to have the next ride, then what it can tell is it can say that, okay, go to this particular place and stay there, and you would get a ride. Okay, this kind of notifications can be provided to the Uber driver. The way we can identify such kind of notifications is based on the past history. Imagine, as I was saying, every day in the 5 o'clock to 6 o'clock in the evening in the financial district, if you have a lot of cab bookings are happening, based on the data, we can extrapolate that in the future also. We can in every day you at that time you can get the same transactions happen. So that is how you can create more applications. Understanding? So that kind of use cases are there. Another interesting application area which I also like is human emotion analysis. Like how to identify facial recognitions, how to identify uh, emotions of humans, and using that we're trying to create application areas. So that is very important. So human emotion analysis is an area where we are trying to look at the images or videos of humans and then trying to depict like whether they're happy or sad or angry, or they are different emotions, right? And excited and so on. So why we are doing this kind of analysis is that nowadays we are trying to create applications which are removing the monotonous jobs of humans. For example, a customer service agent, a very manual monotonous job, maybe like a hotel receptionist, a very manual monotonous job. So in the future, I'm very confident that all those jobs will be removed, and you would be having replaced that with these humanoid robots. I'm not sure, but you might have heard about the humanoid robot like Sophia, which is using deep learning techniques to identify human facial recognitions, human voice modulation, and all that stuff to create replies. So those things are going to take up the world. For example, you're going to a hotel, you're going to a beach hotel, imagine, and you are trying to talk to the customer agent. So what will be your conversation? So you'll go to the receptionist, you'll say like, hi, I have a reservation for so and so date, this is my reservation number. The receptionist will take the reservation number or probably ask your last name or something, and search for the room. And you would also maybe request for something like, can you give me a beach facing room, or maybe a room at a higher floors or something like that. And then based on your request, it will try to allocate, and then say that, sir, thank you, we have allocated a beach facing room, and have a nice day. That is what they will be telling. All this conversation can be automated by using humanoid robots. A lot of these robots can look at human expressions, identify the voice modulation, identify what they are speaking, and then based on that they can automate that entire process. So there are a lot of works in progress, which are applications which are being built with advancements of voice technology, advancements of search processing, advancement of image processing. A lot of these are combined together and then creating a lot of these applications. I'm very sure that in the coming few years, like maybe like 3 to 5 years, you would see a lot of these applications coming in place. Another important area which I worked, this is back in 2014-15 timeframe, is on genomic data analysis. Genomic data analysis is again in a healthcare domain. It is a very important analysis, and current stage, like we are currently in this COVID pandemic part, it is very important to identify how quickly the medicine can come, right? How quickly the vaccine can come. It is a very important step, and a lot of these companies are using data to do extrapolations to create a lot of these extrapolation results. The project we did was trying to identify different gene patterns of humans with respect to different animals. So if you're identifying the entire life cycle of a drug in sense a medicine, for example fever medicine like crocin, you want to invent a medicine like crocin, like it will take a very large time for the medicine to create, invent, and get it into the real market. The large time is required because it would require very stringent test procedures, right? It has to first be tested on lab rats, a lot of lab experiments will be done. It has to have positive results, then it has to be tested on rabbits, monkeys, chimpanzees, and then to the different clinical trials, and then to real approvals, right? If you see, the entire process will take anywhere from 6 months to couple of years, right? Depending upon the complexity of the drug, it might take somewhere around 6 months to a couple of years, and it is very difficult because in the olden days people used to invent the drugs, but if the drugs were having side effects, the people used to sue the drug companies and file a lawsuit on them, and the drug companies used to have to bear a very huge penalties on the lawsuits and so on. So because of that, drug companies are very clear about this entire analysis process. So as a part of the project, what we did was we were trying to identify the gene sequences of humans with respect to different lab rats and so on. For example, I'm testing a rat is there. What is the similarity between rat and humans? Like, of course, they are very different, but there are some similarities. For example, rats have eyesight. Rats have a sense of smell. They will be able to eat. There are different other bodily functions which are very similar to of a rat with respect to humans. So when you're identifying gene similarities, you would see that these genes are similar. And when these drugs are tested, you try to identify the nature of changes in those particular genes. If those genes are very positive, then what happens is you can extrapolate the result to humans, saying that because these genes of rats are positively correlated, using the same correlation, we can say that these experiments would also be positive when we try it on humans. And such kind of analysis, what it has done is it has reduced the entire testing life cycle of the entire process to a very small level. Are we understanding? So instead of spending like 6 months testing on rats, on testing on mouse, testing on rabbits, and you will take a lot of process to do all this thing, you would try to cut down the time, and somewhere around 3 to 6 months is now is an easily doable process to to create a vaccine. And a lot of the COVID vaccine companies are also trying to use this kind of data analysis techniques to extrapolate the gene sequences, identifying the test results on the genes, and then extrapolating those results to the real humans. So this was the project which I did. This used Hadoop and other things. It did a lot of data similarity, pattern matching, and all that stuff. But it's a very interesting project, and which has created a very huge impact on this drug discovery. It's called as drug discovery. The entire process is drug discovery. And in that process, the testing of the drug discovery has come down a very drastic level because of this. One other interesting area which I have a very positive view is Internet of Things. I'm sure you might have heard about Internet of Things. If you have not heard, it is nothing but everything around you. If you just look around, everything around you will have an ability to connect to internet and pass the information through the internet. And using that information, we can do a lot of analysis. Now, that is how it is going to change. It is going to revolutionize the world in the coming years, that everything around us will be connected to internet. Nowadays, there are a couple of things coming up. For example, internet connected TV, internet connected AC, and so on and so forth, like internet connected car, right? All these things are coming, but I'm very sure that in the coming years, you would see that everything around us will be connected to internet, and then you will have names to the products. For example, a fridge connected to internet. I'm trying to give a very simple example. So do you think a fridge can connect to internet and do all that stuff, whatever it is trying to do? Do you think it can do it? Right? So fridge can connect to internet, and it can have some sensors in the fridge, for example, video sensors. It can have some barcode scanners and so on. If you see, there are a lot of research working. These bigger refrigerator manufacturing companies are working on this barcode scan based technology, where, you know, whenever you're keeping anything into the fridge, most of the Western countries, the food is in canned products, so it is already canned. So these are cans are going into the fridge. So it will track like what is the product which is in the fridge. And you know, you can say that, you know, in the coming days, you know, I can give like an example that it can say that fridge can talk to me, saying that, you know, Sitaram, the palak which you have bought like 2 weeks back is there in the very fag end of the fridge. Please either eat it or throw it. Right? It can talk to me like that. Right? And it can also say that, Sitaram, the jam bottle is almost empty. Can you please order it? So if it is a good fridge, it will give this kind of suggestions. If it is a bad fridge, it will order using my bigbasket.com account and then order a jam bottle, and the guy will knock my door, and then I will realize that, you know, my fridge might have ordered the jam bottle. Right? So I'm just trying to give you a little superfluous thought process, but do you think that this is possible? Yeah? A fridge ordering from bigbasket.com, is it possible? Right? So the answers, there could be three answers. Okay, the answer could be no, there could be yes, it can order, their third one will be maybe. Right? So the question is, now we are trying to create applications which are very linking to internet. So the fridge has connectivity to internet. It will connect to your Wi-Fi. It will have access to your bigbasket.com account. Imagine in the coming years, you are centralizing everything with your retinal scan or maybe with some common ID. So it will connect to your bigbasket.com account and then order it, and then it will cut from your Google Pay or some kind of mechanism, and you know, you get an order to your doorstep. It is quite possible, and currently it is not available, but it is very quite possible that such kind of things can happen. And so what we are trying to do is, we are trying to identify an application area, Internet of Things. I will talk about the project which I worked on. So this is a car manufacturer company, which is manufacturing. It is a US car manufacturing company which manufacture cars. Okay, and they have created this project called as preventive maintenance of car applications. So this is a project, preventive maintenance of applications, and the primary purpose of this application is to the car manufacturing company has a huge shop floor, like a huge shop floor will be there, and the car parts will be manufactured, and there will be supervisors who has to go to every machine. They have to collect a lot of vitals of the machine. For example, the temperature of the machine, the viscosity of the lubricant fluid, then the turbulence of your cutting spindle. Likewise, there are a lot of these indicators which are being measured to tell whether the machine is in good shape or not. Okay, so the purpose of the supervisor is every day in the morning he goes through every machine, tries to collect all these vital components, and then based on his intelligence he will decide that okay, machine 4 is not good, it is giving the lubricant liquid or oil has to be changed, and the machine 10, maybe the lathe which is cutting your parts, iron parts, that has already worn out, you have to change that. Like that, based on his intelligence, he used to give that kind of decision making. What used to happen is these supervisors, sometimes they're very intelligent, they used to give accurate results, but sometimes with if the accuracy is bad, the entire production line will stop. Imagine they have not estimated the lathe going bad or lubricant fluid getting overheated. They did not estimate it properly, the machine has stopped, and what happens is the entire production line will stop. So what they have done is, instead of doing that, they used to purchase all these machines. The oil has to be purchased well in advance. They used to keep it in the godown. So that was a big loss in the utilization, because these products are not utilized. They're kept in the godown just for the sake of not taking any chances. So what the company has done is they have changed this entire process to an Internet of the Things, IoT, they call IoT driven data analysis process. So there are a lot of these sensors which are connected. The sensors will sense the temperature information, turbulence of the cutting spindle. They will sense the viscosity of the lubricant fluid, and all those things will be sensed. And they will send this information to a common cloud. So connected to a common cloud, you get all this information from all the machines. And based on the past data, we used to run data science algorithms to identify which machine is going to go bad. It is called as preventive maintenance of the application. We try to identify which machine is going to go bad in the coming weeks, so that in advance we can predict that okay, this machine which is machine number 58 on the first floor of the shop floor is going to go bad. The lubricant fluid has to be changed within 2 weeks, or else the machine will fail. So we can give such kind of information to the supervisors so that they will go and replace it. If at all they would require to do any procurement, they will procure at that time, so that by the time the product comes, they can go and they don't have to keep everything in the godown. They can procure as and when they get alerts, and they will be replacing those parts without any delay. So this car manufacturer company is using this very successfully. So a marriage between IoT and data science is a very powerful thing, I would say, because a lot of data points are collected from these devices which are connected to internet, and then using that data, we're trying to predict what is going to happen in the future using the data science algorithms, and then using that for our analysis, right? So that is the crux of this application. So Google Assistants, the voice assistants, we already looked at it. A lot of these applications are there. They're using speech, they're using voice, text-based analysis. All those things are being used. All of them are part of your data science. One more interesting application area which I've worked, and this is for a popular hospital chain in US. Again, it is a popular hospital chain, and what it has done is these hospital chains, what they do is they collect a lot of patient information. Like whenever the patient get admitted, you will collect all the information of the patient. It will collect all the information and keep the history of the patient. Okay, So you go to the hospital, every hospital collect the information, and in fact, major chains are also centralized. So your patient record will be kept centralized. So all the bodily vitals, for example, what is your age, what is your height, weight, body temperature, your eating habits, drinking habits, every other information, right, about you will be collected. And also your for example, what disease you got. Imagine you got a fever, and you have cold or whatever, sore throat, you have allergies or anything. So all those things will be collected, and using that information, we try to use something called as clustering mechanism. So imagine you have grouped all similar people, right? And this clustering or personalization is done because we have to avoid overdosage or underdosage of medicine. That is a bigger problem for the hospitals and doctors. That, for example, you go to a hospital and you have fever, you will be given one dosage of crocin, and imagine that will solve your problem. Imagine somebody who is very hefty, like a very stout guy, 6 feet 6.5 feet tall, like, and who is having 120 kgs of weight and something like that. I'm just making up things, but who is a very stout guy who goes to the hospital, he gets fever, he is given crocin. It did not solve his fever. Then people realize, doctors realize that because of his bodily nature, he has to be given double dosage of crocin, and then he has given 2 dosages of crocin, and that solved his problem. This is another case. There could be a third case where is a very skinny girl, very skinny girl, like very underweight or minimum weight. If she's going, she's also getting fever, she goes to the same doctor, and he will try 2 doses of crocin or 1 dosage of crocin. And for that girl, it will give some side effects. She might get some skin allergies, or she might get some diarrhea or some other vomiting sensations, nausea, or things like that. She might get some side effects because of this dosage of medicine. So that is a very big problem in hospitals. So because of that, the project came where we are trying to personalize the medicine given to the patients based on their different bodily elements, right? Now, what the hospitals already do is they collect a lot of this information, and the hospitals, the patient information, we used to call it as EMR. EMR is nothing but electronic medical record. Electronic medical record of every patient will be collected, and using that, we are trying to cluster your patients. So what happens? All people who are hefty weight, who are not doing exercise, who are not doing any regular body habits, who have drinking habits, who have smoking habits, imagine those are all into one group. The other group will be regular people who are like very organized, who do regular exercise, have good food habits. All those things become into different group. Likewise, skinny people can become one group, hefty obese people can become another group, and so on. Now imagine we try to create these clusters and identify which medicines were given to that group and which solved their disease and which did not solve the disease. All those things will be tracked. An application is created where, provided a bodily information of a patient, we try to cluster that patient into a known group, and then gives information that, okay, for such kind of people, crocin is used, 2 doses of crocin is to be used, past test results, this much of positivity, this much of predicted ability, all those things will be provided, and that will give doctors an information that we can use this kind of information for treating future patients, right? It does not remove the job of a doctor. Doctors will still be there, but it will overcome the problems of the patients. Are you getting it, guys? So using the techniques like clustering techniques, so we can use k-means clustering, you can use hierarchical clustering. A lot of internal data science techniques are there. Using those techniques, we're trying to predict like how we can use things to create these meaningful groups, so that once I personalize this, now I can say that because of the age group, so you can create people who are like similar age group. So all those people will be coming into one group. Then we can see like what worked for those groups. So we can give same medicine to that group so that it will help them for the future purpose. Okay, got it? So let me see. Okay, so I will take some questions. So any questions you have, any general questions or anything related to whatever we discussed? So we are discussing so much of information, believe me, this is a 3-hour session. So as you see, we are trying to talk a lot of things. In fact, we took a little break in the middle and discussed a lot of things, general things also. But my intent is to provide you an understanding of this entire area of data science. How is this going forward? All those things. So if you have any questions, please post that. I will be happy to answer. We will be discussing about an end-to-end life cycle of data science. There is a lot of important topics to be discussed. So you can come tomorrow and we will be discussing those things. I'll be looking at a couple of questions. I'll answer those things and then we will close. Let me look at the time. What is the time? How much we have? 8. Okay, 35. Okay, I'll be taking some questions. What is supervised machine learning algorithms? What type of data, label or unlabeled data used for categorizing the continuous values? One real-time example. So for example, supervised machine learning algorithms are, as I was talking, right? So we have the data which could be labeled data, unlabeled data. Typically supervised machine learning algorithms, semi-supervised, okay. Semi-supervised machine learning algorithms are where you have data, but you don't have so much of labeled information. For example, one application which I worked on for the hotel chain, they have a lot of images, okay? Images where, for example, hotels, you go, you see the images of rooms. You see images of rooms, you see images of balconies, bathroom images will be there. You will have images of, like, say, gym or swimming pool, like that. Now people will be uploading their images also, right? There will be images posted by the people who stayed there and posted by the hotel chain. So the problem is when the people are posting images, I have to exactly tag those images into particular areas, right? Or else there will be very unorganized. So what we want to do is we want to automatically tag that into specific areas. Like, say, swimming pool images are there, it has to automatically tag that these are swimming pool images. Some other images are there, you have to tag them automatically in that particular area. Like, say, images about room, okay, room images like bed and facilities and so on, that has to be automatically tagged. Some people might give images of bathrooms and other facilities and so on there, gym lobby, like that. So so for semi-supervised learning, what we do is we already take basic data, we do manual annotation. So manually I have to look at the images and then I say, okay, this is images of our rooms, this is images of swimming pool, this is images of bathrooms, this is images of hotel lobby. Like that I do annotations, but that is a painful process. So imagine you do annotations and then you apply your machine learning algorithm. That is what we call as semi-supervised. You will not have fully supervised data. You will have some supervision, some annotation done, and then you would try to extrapolate those results, which using the other ones. Got it? So there's a question that whether tomorrow's session will be recorded. Yeah, these sessions are recorded, but I request that if you have time, you can definitely attend the session. It is very important. In fact, today's session was more general to make everybody aware, because we will have so many different groups of people. I tried to start general. Tomorrow I will talk about more application, not application oriented, the approach oriented, like how entire life cycle of data science works in real world, what are the different components which are involved, where there are a lot of job opportunities. We will discuss about all right. So what are the types of bots? What is the difference between Rasa and Dialogflow? So the bots can be divided. So chatbots, now I can divide chatbots into multiple cases. I can write my own chatbot by using pure programming language, or I can use some tools. Rasa, Dialogflow, AWS Lex, and these are all different tools which are used for creating chatbots. So in chatbots, data science it's an application area of natural language processing. So in chatbots, we have to create a lot of things like what is the intent of the chatbot, what is the utterance. Like for example, I would like to book a ticket. I would like to book a airline ticket. If I'm saying to the chatbot, it will ask like, okay, sir, when do you would like to book a ticket? And I will say I would like to book a ticket on 30th July. On which location, what is the economy or business class, like that. So you see, this entire information has to be tracked, and then you have to create an entire end-to-end chatbot. For doing that, we have these tools. Rasa is one of the tools, Dialogflow is one other tool. There are cloud provider tools are also there, which could be used for building those chatbots. API.ai is there, Vid.ai is there, Amazon Lex is there. So all those things could be used for building those applications. So there is a question that I'm a Java developer. Will it help to migrate to the future? I know many of my friends who have worked in pure Java applications. They used to work on JSF. They used to work on structs and Spring Hibernate applications, and now they have converted into data science professionals. Only thing that if you want to be in technical work, you need to have understanding of all these tools. You need to have ability to program and other ones, right? If you want to get into something like a techno managerial role, then you might not require a lot of code based things, but it is always advisable to understand what is the base of the coding, like what is it related to and other stuff, right? So that is something which is required, and it is possible. It is not like it is not possible. Depending upon your years of experience, you have to play a different game, right? If you already have a clear-cut experience, you try to identify whether within your company are there any projects so that you can easily migrate there, work there for some time, and then create it. Or else you need to work on a lot of projects, because nowadays people are giving more preference to practical learning than a certificate or, right? Because I conduct a lot of interviews. I request everybody to go on mute, please. So we need to plan our journey accordingly. You need to identify what technologies you want to learn, what level of technical involvement you need to have, your years of experience. All those things matter, and based on that, you have to plan your entire transition. And it is doable. Many of my friends have done it, so it is practically possible. Only thing that how do you do it is a question. So in the earlier chart, I've asked whether PCA is applied before the visualization. PCA is applied before the visualization and after the visualization also. Generally, PCA is done. PCA is something called as principal component analysis, where I'm trying to reduce the dimensionality of the reduction. So generally what we do is we do data visualization, identify the similarities of the data without applying PCA. Because if I have already applied PCA, what happens is your entire data will be transformed into a different dimension. So what we do is we apply data visualization before PCA, identify the patterns, you get some domain expertise also, you do all that stuff, and then apply your PCA before applying your model. That is how the steps will be. So can a Java developer go for this? What is the prerequisite? A Java developer, because he or she is a developer, he has already worked in a code-based things. So if you have understanding of any language, that is good for it. You can try to learn Python, which is the basic for most of the data science projects, and then you can go for it. So what are the average pay scales of big data developer, big data engineer, and admin? See, this is I would this is what I would say is very specific question. It could be area dependent wherever you are. It would depend. So I would recommend to do a little research on say like there are sites like Indeed.com, or maybe like what is the other one, Payscale or something like that. I forgot that website name. So it gives different salary ranges by the location, right? So those websites, I think you could look at it, and that would certainly help you in that. Okay. So pardon me, I'm just scrolling through the questions. By the time I come to your question, I think it will take a little time. Freshers will get Java as a Tableau developer or not? Tableau developer, yes, you could get job as a fresher. You need to become as a data analyst or data visualization, junior data visualization expert. So that are some of the basic job roles which are available. Tableau developers, there is a requirement. Yes, people are required. For anything, see, I would request that for anything, whatever you want to target for the job, you try to see that the horizon in which it is going to sustain for the coming years. And also you do a project oriented learning, right? Whenever you are either learning or you're doing some things, you try to ensure that you're doing a lot of projects in that, which will help you to project your capabilities. Like people wants to get people who can do hands-on, right? I want to hire somebody who can do hands-on. I don't have to retrain him or ensure that he will get up to the mark in couple of months. I want somebody ready-made. For getting a ready-made thing, you have to ensure that you are doing the learning which is more real-time, more realistic, more project oriented. Then that will help you get a better position. So what is an average package for an experienced guy? Again, it is a very subjective question. I would recommend to search in many portals like Indeed.com, Naukri.com, depending upon which area you are. So there are the job portals which provide pay scales, or Glassdoor. Sorry, I forgot that. Glassdoor is a website which can give those pay scales, right? Depending upon the area you are, you can put that job roles, and then it will give an average salary for that, depending upon the experience and all. Got it? Any other questions, guys? Any more questions? I hope you are I hope you are understanding whatever we discussed. It's a 3-hour ride. I'm sure it should be not a bumpy ride. I hope you are able to get some information from whatever I'm speaking. And please let me know if the session is very fast or very slow, or is it okay? You are able to understand my language. Anything you have something, you can just provide me a feedback, which will certainly help me in developing my own way of telling, right? So I would just require that feedback. But overall, if you have any general questions about the session, just let me know. I'll wait for a few minutes. If you don't have any questions, we can wrap up today's session. Tomorrow, I will talk about a very important thing where I would like to walk you through a different life cycle of different components of machine learning, like how do we do which process, where are more jobs, what all those all things we will be discussing. Now, because somebody is more in line towards somebody is more in line towards like admin kind of roles, because they have he or she worked as a system admin in the past, and somebody who is in the testing domain, somebody who is in some other domain. So there are different kind of job requirements, but so depending upon where we are trying to fit, somebody coming from a testing domain, so where will that person fit exactly? Somebody who is coming from a front end domain, right? Maybe like a web developer kind of a domain, where he or she will be fitting. All those things we will be discussing in great detail. I'll try to put my more practical experience of how this entire landscape of data science is there. So we'll discuss those topics. All right. I hope you are liking it. So if somebody says the language is good, a bit faster helps. Yeah, so a bit faster, a bit slower, depends. I'll try to speed up or slow down on the topics, because today is the first day. I don't want to rush things, so I went a little slow, but certainly we'll do it. Okay. Do we need to learn any technology before learning data science? I would say Python language is kind of a prerequisite. If you learn that, you are so it will help you to work. Okay. So I myself do trainings in Python and data science. So I'm more of a data scientist. So Python language is covered as a basic or included as a part of the course. Okay. So if you're really interested in any of the course, please get in touch with our coordinators. They will certainly talk to you, provide any information which you require. They will talk to you. You can coordinate with them. Certainly they will be able to help answer any questions regarding the course or anything based on our interest. Okay. So today's topic is not only about the course part, it is more about understanding these all topics and make you understand like how all these things are working, right? So tomorrow also please do join. Very important topics to be covered. It doesn't matter whether you join the course or not, but certainly it's important for you guys to understand. So that is something which to be covered. Got it? I think I'm not missing any questions. Can you provide us the job roles and required skill sets? Yeah, that is for the topic for tomorrow, because it is little in depth, so it will require a couple of hours to talk, right? We have already exhausted 3 hours of our time today.
Hello. Yes, Sitaram Garu. Sorry to interrupt you. Hi everyone. We hope that you are all enjoying with this session. And tomorrow we are going to have the session same time. So please make yourself free to attend the session. We are going to have the same link only. And already we have shared details to get the recorded sessions, and please subscribe to our YouTube channel. I'll be sharing that link today. Thank you.
Hi, mentor.
Yes,
Hello.
yes, please. Yes, someone is talking.
I have one question. This is Motilal Kumar. So, along with training period, are you providing placement kind of things?
Yeah,
Hello?
we will be discussing with you very soon. We are going to have the regular sessions, which is of like 45 days to 2 months training. We are going to have it, and I'll be sharing those details tomorrow in tomorrow's session. Okay, so if you take that training, then we'll be giving all this. Okay.
Okay. Thank you, ma'am.
Yeah, thank you. Bye.
Bye.
Okay, guys, thank you very much. Have a nice day. Good night or good day wherever you are, and stay safe. Bye bye. We'll discuss tomorrow.
Thank you. Bye.